All right.
Okay.
I'm not sure where we left off. What do you got in the way of new problems here?
Let's see.
We did a complete the square. The last one we did was putting it into vertex format. And I really
Right,
don't know how to do that other than completing the square.
right.
You kind of have to start with standard format and then complete the square in order to get it into vertex format.
Okay. Yeah. Well, it says next, so like with that same equation, it says to write it in standard form and intercept form.
Okay. We wrote it in standard form.
Yeah.
In other words, it didn't start out in standard form. What was the equation again? 2x?
It was the original one.
Yeah.
3x squared minus 6x equals 6 parentheses 2x plus 8.
Okay, that's not in any format there. But after we distribute the 6 and move everything over to the left, we had
Y equals 3x squared plus 18x plus 48.
I think it's minus 18x
Oh, yeah, you're right.
and minus 48. So there's standard format right there. Okay. And then remember the steps for completing the square. You separate out these two terms, put parentheses around it, put that number off to the right, so I haven't changed it. Now in order to complete the square, I factor out the 3 from just inside the parentheses part. Leave some room. Now complete the square, take half of 6, square it, add it. We just added 27 to the right side, so I got to subtract 27. I made a mistake before, didn't I? Is that minus 48 or plus 48? It is minus.
Yeah, I think it's supposed to be minus, but we wrote plus 48.
Ah, so I made a mistake there. Okay. Yeah, because I remember I did have it as plus. When I move it to the left side, it becomes minus. So,
Okay.
okay. And then, of course, since we've completed the square, I can write this as x minus 3 squared. Combining those two, I get minus 75. There's your vertex format.
Okay. And then from those two, it asks me to write it in intercept form.
They want you to write it in intercept form?
Yeah.
Okay, intercept form is y equals a times x minus p, the x-intercept, times x minus q, the other x-intercept. Okay. This might factor, actually. So let's go up to standard format.
Okay.
Let's start there. What's the first thing I can do there? In other words, if I want it in x-intercept format, can I start by, what's the first step in factoring? Or what's the first step in trying to give this to that format?
Um.
Their greatest common factor.
Yeah.
Always start there. Whenever you're factoring anything, start with greatest common factor.
You could factor, or the greatest common factor is 3, I think.
And that leaves something that I can probably factor. Yeah. So now if I can factor that quadratic, I got it, right? In other words, notice what, that's the format. That's intercept format. Well,
Okay.
I'm going to have an x and an x. What are my signs?
They'll both be negative.
No, there's
Or
only
one.
one way to produce a negative 16 when you FOIL something together. And that's if your signs are opposite.
Oh, okay.
Now what? Now I want factors of 16 that do what?
That multiply to negative 6.
Subtract, because of that, to the number 6. Just that.
Okay.
Well, that's 8 and 2. 8 and 2 subtract to 6. Take the larger of those factors, put it with the sign of the middle term, minus. Take the other factor, put it with the other sign, and there you have it.
Okay.
And that is in intercept format. In other words, the intercepts are -2 and +8. So if I wanted to graph that from intercept format, I would find the intercepts. There's a -2. There's the +8. You know, it opens up, so it does something like that. I still don't know the vertex because we never solved for the vertex. However, I do know where the line of symmetry is. Where's the axis of symmetry? And that gives me the x-coordinate of the vertex. So intercept format is actually a pretty powerful format.
Mm-hmm.
How would I find out where this line of symmetry is?
Well, by plotting the x-coordinates and like finding the halfway point.
Halfway between these 2 points. Well, what's halfway between these 2 points?
3, right?
Yeah, what you do is add the 2 numbers and divide by 2.
Okay.
And that's 3. 3 is 5 units from -2, and it's 5 units from 8. So now I do actually know the vertex x-coordinates is 3. And if I want the y-coordinate, just plug in 3 for x. So I have 3 times 5 times -5. That's -75 is the y vertex.
Okay.
Unless I did the math. That seems a little negative, but did I do that right? Let's see, I plugged in 3 for x, which gave me 5 times 3, or 5 times a -5. That's -25 times 3 is -75. Yeah.
Okay.
So you can kind of see where each of these formats has its strengths and its weaknesses.
Yeah.
But the main thing to know is that there are 3 formats. There's standard format, there's vertex format, and there's intercept format. And you actually need to be able to go to the other 2 given one. If they give you one format, you should be able to come up with the other 2.
Okay.
And then there's this format, which is no format at all. That's just an equation. We can put that in standard format by bringing everything over to the left.
Okay.
All right. What else you got?
Okay, when it asks to find the discriminant, what does that mean?
Okay. There's a reason it has its own name. The part that's inside the radical sign is the discriminant.
Okay.
That's the b squared minus 4ac.
All right.
And the reason it has its own name is because a lot of times when you look at a quadratic, you want to know whether it has real solutions or imaginary solutions.
Mm-hmm.
Well, that's completely dependent on whether this discriminant is positive or negative. If it's positive, you're going to have real solutions, 2 of them. If it's negative, you're going to have 2 imaginary solutions. And
Okay.
if it's exactly equal to 0, then you're only going to have 1 solution, which is that. other words, if it's equal to 0, then this plus or minus doesn't play. So that's what the discriminant is, and that's why it has its own name. There's a lot of times when I look at a quadratic that I want to know whether I'm going to get complex or real solutions. If I'm going to get complex, I may not do it. There's a lot of problems in math where if it produces complex, you don't factor it. If it produces real, you do. So that's a nice thing to know. And the way you find out is by analyzing b squared minus 4ac. And it's not the square root of that. The discriminant is just this part here. That's the discriminant.
I see. Okay.
Okay. So do they give you some where they want you to solve for the discriminant?
Well, yeah, they asked that, but I know how to do it.
Okay.
Let's see what. Oh yeah. Okay. So it says simplify the expression with no radical in the denominator.
Okay.
And it's so it's square root and then 25 over 3.
That's it?
Yes.
Well, that's
Or
fine.
it's square root. The square root is both of them.
Ah,
Square root.
okay. I was going to say, that doesn't fit what you described. Okay. You cannot have an irrational number in the denominator. That's just not a good way to present a problem. Okay, well, let's first of all take the square root of 25 and then put it over square root of 3. Now, how do we it's called rationalizing the denominator, because currently it's irrational. But I can make it rational. I'm allowed to multiply any fraction by the number 1 without changing its value. And I can make that number 1 look like a lot of stuff. Well, in this case, my number 1 is going to be square root of 3 over square root of 3. That's the number 1. By multiplying this fraction by this, I transfer the irrational part to the numerator. Excuse me. I think I'm allergic to Donald Trump. Oh, excuse me. I didn't say that. Let's see. So rationalize this for me.
Okay.
Same thing. I got an irrational denominator.
Okay. So you'd multiply it times square root of 2 over square root of 2. And you get 1 square root 2 over 2.
So that number is exactly the same as that number. It's just in a more presentable format.
Okay.
Okay? That's all there is to rationalizing denominators.
Okay.
Now, there is, let me just say one thing. If I was taking the square root of 1/2, that actually requires rationalization. Why? Because the square root of 1/2 is equal to the square root of 1 divided by the square root of 2, which is equal to 1 divided by square root of 2. So sometimes you'll have a fraction that doesn't look like you have an irrational denominator, but you actually do. In fact, anytime, if I had square root of 1/3, 1/3, that's 1 over square root of 3, which becomes square root of 3 over 3. After rationalization.
Okay.
Okay. What else?
It says...
Your test tomorrow?
What?
Is your test tomorrow?
Yes.
Okay.
It says solve the equation for the given variable.
Okay.
And it's t squared over 20 plus 8 equals 15.
T squared over 20 plus what?
8 equals 15.
Okay, what's the first step?
Subtract 8 to 15.
Correct. It's not to multiply everything by 20. Notice
Okay.
that we can multiply everything by 20, but then that turns into 160. That turns into 300. We're really getting big numbers, and we don't need big numbers. We want to keep everything as small as possible. Well, if I subtract 8 from both sides, we've just reduced that. Now, what?
Could you multiply everything by 20?
So we have t squared equals 140. Now what?
Square root both sides.
What's t equal to?
So t is equal to plus or minus.
Let's write it like that and then see if it can be reduced.
Okay.
The key part was the plus or minus. About 90% of my students forget that. Not sure why, but it's one of the tougher things to remember in math, is that plus or minus. In other words, whenever you solve an equation by taking the square root of both sides, always begin your answer with the words plus or minus.
Okay.
Now, let's talk about, can we reduce that? Well, the question is, does it have any factors that match these numbers? Any of those numbers? Don't have to go much higher. I'm not going to find a perfect square number that goes into 140 bigger than this. But which of these divides into that?
4 does.
Okay, let's start there. So it's the square root of 4 times what? When you divide that by 4, you get 35.
Yeah.
Okay, which becomes what?
Which becomes 2 square root 35.
Yeah, now can I break 35 down anymore?
I don't think so.
No, it could be square root of 5 times square root of 7, but that doesn't help. In fact, that's 2 terms instead of 1. So only time you break it down is if you can pull a whole number out. In other words, this has to have a factor that matches one of those numbers for it to be broken down further. Okay, so your answer then is t equals plus or minus 2 root 35.
Okay.
What else?
Okay. Okay, write the equation y equals 4 parentheses x minus 3 squared minus 2 in standard form.
Okay, what format is it in right now?
Vertex form.
Okay, so to get it in standard forms, all we have to do is expand it.
Yeah, okay.
Okay, so what do you expand first?
The x minus 3.
Okay, what's that expand to?
That should expand to, hold on, I'm writing it out. So that'll be x squared minus 3x minus 3x plus 9.
Okay. Notice, remember when we completed the square?
Yeah.
It looked exactly like that. That's why I could turn that into x minus 3 quantity squared.
Okay.
In other words, whenever it's a perfect, when you have a linear term and you're squaring it, it's going to end up looking like these kind of answers. And we still have the minus 2. What's the next step?
To distribute the 4 to everything in the parentheses. Okay, so that'll be.
And finally, the last step.
Subtract 2 from 34.
Okay. And there you go, standard format.
Okay.
In other words, standard format's the easiest one to put everything in. Even if I started with intercept format, where it was x minus p times x minus q, just multiply them all together and you end up with standard format.
Okay.
It's going from standard format back to vertex format that's a little tricky. In other words, if we started with that, we'd essentially have to go through this completing the square process.
Right.
To get it into vertex format.
Okay.
All right.
And then there's this one thing that was pretty hard too, but it says simplify each problem on a separate piece of engineering paper. And there are questions like negative 2a squared and then b to the third over
Hold on. Start again. Minus 2a squared.
Yep, and then b to the third.
Just b to the third like that?
No, times. Well, like times b to the third.
Okay. I didn't hear the times. Okay.
And then over 14ab to the fourth.
Okay. Is it the whole ab to the fourth or just the b part?
Is what?
Is it the entire ab to the fourth or just the b to the fourth? Now, there's a difference between these two expressions. In the bottom one, both of them are taking to the fourth power. And the top one is just the b that is to the fourth power.
Yeah, I think it's just the b.
Yeah, I'm guessing it is too. Okay, well, let's start with the numbers. You start with the numbers and then you do the first letter and then you do the second letter until you're done with all the letters. So what's minus 2 over 14?
Negative 7.
Negative 1/7.
Oh.
In other words, I'm going to divide top and bottom by 2 to get 1/7.
Okay.
Now, let's look at the letters. What is a squared, the numerator, divided by a?
Would that just be a to the third?
No, you subtract exponents when you're dividing.
Oh, so it'd just be a.
What's b to the third divided by b to the fourth? Taking the b's.
And so you're subtracting the exponent. Well, b to the negative third.
Okay, and I can write that either as b to the negative 1 there, but undoubtedly they've told you no negative exponents in your answer, so that b ends up going down there to the positive 1.
Okay.
That's the answer. I don't need that 1, but I do need the negative sign, so simplifies to that.
Okay.
Okay, and that's the way to do all of these, is to do the numbers first, then the next letter you come across, and then the next letter, and so forth. You could have 5 letters in the numerator. It wouldn't matter. It doesn't make it tougher. Just have to go through all of them. Let's just make sure you know your rules of exponents. What is this equal to?
Would it be x to the fifth?
Did you say 5?
Yep.
Okay. What is this equal to? Subtract exponent.
Would it be x to the negative 7?
Subtract exponents.
Oh, x to the 6th.
And finally, what is this? In other words, here's the 3 things you can do with exponent. You can multiply the same base where you add the exponents. You can divide the same base where you subtract the exponents. And you can exponentiate twice. What's
So
that equal to? X cubed squared.
so x cubed is, would it be x to the 9th?
No, you multiply the exponents.
Oh, so just be x to the 6th.
Yeah, so there's really only three things you're going to do with exponents. You're either going to add the exponents, you're going to subtract the exponents, or you're going to multiply the exponents.
Okay.
And you're always doing, the way to remember that is you're always doing one level less mathematically. Now, notice that I'm multiplying there, and I'm adding the exponents. Addition is one level less than multiplication. Here, I'm dividing and I'm subtracting the exponents. Subtraction is one level less than division. And here, I'm doing exponentiation. And one level less than exponentiation is multiplication. So I'm multiplying the exponents.
Okay.
Okay?
So another one of those, there is parentheses 2x to the 4th
Is the 4 inside the parentheses or outside?
inside. And then y to the negative 3rd. It's still in the same parentheses.
Oh, okay. It doesn't much matter on these.
Oh, okay. So y to the negative 3rd.
Okay, yeah, because they're all multiplying.
And then z, and then the parentheses ends, and then it's all to the negative 3rd.
Oh, all to the negative 3rd like that?
Mm-hmm.
Okay. So I'm going to do one at a time. Let's take, in other words, that negative 3 applies to everything in the parentheses.
Okay.
So what's 2 to the negative 3?
Negative 6.
No. A negative exponent merely means it's a reciprocal. So it becomes 1 over 2 to the 3rd. That's what negative exponents mean. 2 to the minus 4 is 1 over 2 to the 4th. In other words, they're not negative numbers. They're positive numbers, always.
Okay.
It just means reciprocal. Okay, so that's 1 over 8. That's the number part. Now apply that minus 3 to the x.
Okay, so then it would be negative 12.
So it's x to the minus 12. For the moment, I'm going to leave it in the numerator just until we get done. Now, do the y.
Y to the 9th.
Okay. And the z.
It'd just be z to the negative 3rd.
Okay. Now, you want to put all the things that have negative exponents on the other side of the fraction bar. Don't need that 1. The 8's still on the bottom, and the y to the 9th is still in the numerator, but the x to the 12th goes down here, and the z to the 3rd goes down there. There's your answer.
Wait, why did you move those down?
Well, because typically they don't want negative exponents and answers. I don't know if you were given explicit instructions to have no negative. Almost every student I've ever had has that instruction. Is that they want you to give the answer with positive exponents. Well, this is the same number. That's the same answer. Both of what I have circled are the same things. It's just this one has some negative exponents and this one doesn't have any. Remember, all you have to do to get rid of a negative exponent is move it on the other side of the fraction bar.
Okay.
So that x to the minus 12th became a denominator of x to the 12th. And it goes both ways. In other words, if I had this, and I want to get rid of the negative exponent, I move it to the other side of the fraction bar, and it becomes that. You with me?
Yep.
So whenever you see a negative exponent, you can just move it to the other side of the fraction bar, no matter whether it's denominator or numerator, and it works. Turns it positive. Okay?
All right. Is my brother's session a half an hour or an hour?
It was a half an hour.
Oh, okay.
But like I said, I can give you more time if you need it.
Okay, well, I think I'm good on all my questions.
Okay.
But
Did he need any time at all?
No.
Okay. My next appointment isn't until 8 o'clock tonight, so if you feel like you need more time, feel free to call me, and I'll give you a half hour at 7:30 or something.
Okay.
Okay?
All right, well, thank you for all your help.
You're welcome, Anna.
All right, I'll see you. Well, I'll actually let you know if I have any more questions.
Okay.
Okay, thank you.